Hi everyone. We are on YouTube University. This semester, together, we are going to cover statistics for social sciences. Let me show you the book that I'll follow. Just a second. This is the book I'll follow, and then it's an online version. It is in public domain, so there will be no copyright issues. So what we will do in this class, basically, we will start with introduction, then graphing distributions, then we will summarize distributions, describe bivariate data, probability, which is an important topic. We will a little bit touch on research design. We will cover normal distributions, sampling distributions, estimation, logic of hypothesis testing, one of the most important topics this semester. Testing means, we will test the population means. Regression, analysis of variance, ANOVA, and to explore the association between categorical variables, we will also cover chi-square tests. And finally, we will a little bit talk about effect size. I hope we can have time to cover all these topics. Let's get started with the introduction, basically. So when we talk about statistics, actually what we talk about is basically numerical facts and figures. So for instance, if I tell you the largest earthquake measured 9.2 on the Richter scale, it means I am giving some numbers, right? And this is a huge earthquake. Men are at least 10 times more likely than women to commit murder. This is another statistic, basically. 1 in every 8 South Africans is HIV positive. So those are all statistics. It means statistics is about numerical facts and figures. There are some more examples here, which is not very, very important. However, we should understand statistics are not only facts and figures. They are something more than that. So there is a more dimension to it. So statistics, therefore statistics refers to a range of techniques and procedures for analyzing, interpreting, displaying, and making decisions based on the available data. Okay. So those are some more sentences. Okay. So when we think about statistics, basically, there are two branches. One of them is the descriptive, and the second one is inferential statistics. Okay, we will cover both. Okay, so descriptive basically are numbers that are used to summarize and describe data. When you think about descriptive statistics, you can think about mean, median, mode, standard, deviation, variance, and so forth. Okay. So what we do, when we give descriptives, basically, we don't generalize. We don't generalize the idea. What we do, we just give you the sample data. We just give you sample data. Here's an example in table 1. That table shows the average salaries for various occupations in the United States in 1999. Okay, you see the doctors, they are the ones who made the largest sum of money, right? And then at the very bottom, floor designers made the smallest amount. Okay. Here's another one. Number of unmarried men per 100 unmarried women in U.S. metro areas in 1990. As you see in Jacksonville, North Carolina, there are 220 men per 100 women. Whereas in Sarasota, Florida, there are only 66 men per 100 women. As you see, we describe the data. So that's why it is called descriptive statistics. Okay. Here's another example. So we have actually, so let's talk about inferential statistics a little bit. When we talk about inferential statistics, we need to cover two important concepts. The first one is the population. Population is all the units we are interested in. So that's the population, the larger one. So when you take a small subset, so it is a sample. So by using inferential statistics, what we do basically, we use sample data. We use sample data to make inferences about population parameters. So this is our main objective when we use inferential statistics. It means that if you increase the sample size, you will be better off. Why? Why? Because you will kind of catch the total population. So the larger your set is, the larger your data is, the more likelihood that it will resemble the population. Okay, it will resemble the population. When do we use this idea? We use this idea every day. Like when you think about elections, right? Before elections, we will have polls. So what we are basically doing, we are sampling from a large population. Why? Because it is more feasible, right? We cannot reach every voter before the election. So what we do, we sample certain number of people, and then based on their preferences, we try to predict a percentage of vote for a person or for a party. So we use this idea before elections heavily. So it means sample is a smaller subset of the population. Okay. Those are some more examples. Okay. So we have some methods to draw the sample from the population. One of them is the simple random sampling. This is maybe the most used method and the safest method. So this depends on pure chance. So such sampling requires every member of the population has an equal chance of being selected into the sample. And then selection of one member must be independent of the selection of every other member. So that method is based on pure chance. Okay. Does sample size matter? Yeah, it really does matter. Sample size really does matter. Therefore, the sampling procedure, rather than the results of the procedures, define what it means for a sample to be random. So we have to do the job properly to have a representative sample. Okay. We may have some more complex sampling methods. We will cover one of them later. We may talk about random assignment a little bit. So random assignment is related to experiments. So in experiments, we randomly assign treatment combinations to units. So it's called random assignment. Okay. So it is different from random sampling. So when we talk about random assignment, it means we are talking about designed experiments. We are talking about designed experiments. Random assignment. So when we say the random sampling, we talk about either observational studies or surveys. Okay, so there is a difference, a very important one, between the two concepts. So random sampling and random assignment are two different concepts. Let's talk about a more complex method of sampling. It is called stratified sampling as an example. So what you do basically in stratified sampling, you first identify members of your sample who belong to each group. Then you randomly sample from each. Let's assume you have, in a given university, you have 5,000 students, okay? And say, then you will draw a sample from 5 different departments or 5 different colleges, let's say. So engineering, let's assume we have 500 total students in engineering, and then art, let's say we have 100 there. So medicine, let's assume we have 100, 500, and then let's say we have engineering, art, medicine, social sciences. Let's assume we have 1,000 students, and then another department, let's call it other college, and then we have 1,000 people. Let's assume we will take 200 students for a given study. As you see, you have different numbers of students in each department. So you need to use like a proportion to do the proper stratified sampling. So what it means, let's add them up, 2,000, 2,500, right? 2,500, 2,600, and 3,100 students that you are interested in. So you will take 200, right? 200 students. So which one has the largest share? It is the social sciences and the others. It means you have to take proportionally, let's say in 3,100, you will select 200. So we have 1,000 people here. We will do the math, right? And then if we do the math, let's see whether I have my calculator with me. Yes. If I do the math, 200 times 1,000 divided by 3,100 It means I need to take 65 students from social sciences, 65 from other college, and then this is half of it, so 33 from medicine, and then this is right only 100, so 33 divided by 5, so we will take 7 students from this college and then another 33 from this college. So this is called stratified sampling. It is a little bit more complicated, but it helps you to get a more representative sample. It's an important method. Okay, we may talk about variables. And then when we talk about variables, we can talk about dependent and independent variables. So let's look at this case. When a variable is manipulated by an experimenter, it's called an independent variable. In most stat books, independent variable, let's call it IV. IV is the X variable. The other one, dependent variable, DV, is called the Y variable. Okay, so it means let's look at this example. Can blueberries slow down aging? Okay, a study indicates that antioxidants found in blueberries may slow down the process of aging. In this study, okay, 19 months old rats were fed either their standard diet or diets by either blueberries. So this is a treatment. So we have the standard diet, right? And then we have blueberry, right? Strawberry, that's called STR, and spinach powder, CP. Okay, so what we do, we manipulate the diet. Since we manipulate the diet, it means diet is our independent variable. So what we are going to measure at the end of the experiment is going to be our dependent variable. After 8 weeks, the rats were given memory and motor skill tests. So it means these test scores will be our dependent variable. So we hypothesize that, right, the diet affects the motor or memory skills for rats. So it means the independent variable, and it has 1, 2, 3, 4, 5 levels. Why? Because I think one group did not take any. So 5 levels of X. Okay. So dependent variables, memory test or motor skills test. So the numbers we get from this test is going to be our Y variable, which is the dependent variable. Okay, here is another one. Does beta carotene protect against cancer? So it's a vitamin A. Okay. Okay. Or placebo, their hand was the cancer rates for, okay. So what is the independent variable? In this case, we manipulate, right, the beta carotene or placebo. Placebo means we didn't give anything. Okay, and then what is the dependent variable? This is dependent variable occurrence of cancer. So this is going to be our X variable, and this is going to be our Y variable. Okay. The levels, I have already talked about it. So when you manipulate the X variable, so the number of X's, X1, X2, X3, X4. So if it has 5 levels, it means you have 5 different treatments. You have 5 different treatments. We may also cover qualitative and quantitative variables. Qualitative variables is about quality. Okay. Not necessarily numerical values, just the quality attributes. Okay, so for qualitative variables, we have hair color, eye color, religion, favorite movie, gender, and so on. Okay, is there an ordering here? No, there is no ordering. There is no ordering in this one. And then qualitative variables are the variables that are also called categorical variables. Quantitative variables, they are measured in terms of numbers. Okay, and some examples include height, weight, and shoe size. Okay. Discrete and continuous variables, like the number of children in a household, it is a discrete variable, so it has to be an integer, right? You cannot have 2.5 children in a house, no, right? So discrete variables is numerical and it's gonna be the whole number, integer, okay? Time to respond to a question, and this is a continuous variable, right? Because we can answer the question in 0.5 seconds, or we can answer the question in 2.5 seconds. So this is called continuous variables. Okay, I hope this is clear. We may talk about percentiles a little bit. Percentile is an important concept, okay? So when you say in a given exam, I am at 90 percentile, it means your score is better than 90% of the class. So it means, let's say if there are 100 students in a class, and then if you are at 90 percentile, it means 100 times 0.9, so 90. So your score is better than 90 students in that class. So only 9 students scored better than you. Okay, so that's the percentile. It's an important concept. Okay. Like those are the test scores. And that's the formula for the percentile. Okay. Okay, let's see whether they have a question here. So there are how many quiz scores here? Let's see, 20 quiz scores. Okay. Okay, let's calculate 25th and 85th percentile. So 25th percentile, it means let's find the location of 25th percentile. We need to find this value by, let me get the formula, yes. R is equal, R means is the rank, 25 divided by 100. So how many people, how many students are there? 20 plus 1. So 5.25. So what I need to do is basically 1, 2, 3, 4, 5. So the rank is gonna be 5.25, right? So the score is gonna be between 5 and 5. So since it is between 5 and 5, and the answer will be, so 25th percentile will be 5 for this question. Right? Okay, yeah, like this one. For the 85th percentile, let's do the math again. 85 divided by 100 times is 17.85. Okay, let's go there. 17.85 is the location. So this is 17 and this is 18. So it's going to be very close to 18. So our answer is going to be very close to 10. So you can do the interpolation, but it is not that important. So it's going to be very close to 10. Let's check what the exact score is. Okay. Yes, 9.85. If it is needed, you can do the math, but it is not that important. Okay. This is called interpolation. Okay. So this is the percentile basically. We may also talk about level of measurement. Another important concept. We have types of scales. Okay, we have a nominal scales. When we say nominal, it means there is no order. And then the variable is going to be qualitative. So when you think of gender, handedness, favorite color, and religion, those are all measured on a nominal scale. So they are measured on a nominal scale. So there is no order associated with this scale. So for the ordinal scales, there is an order. There is an order. Like you can say for a product, you can be very dissatisfied. You can be somewhat dissatisfied, somewhat satisfied, or very satisfied. So there is an order. So this scale is called order. So what differentiates between the two is basically the order. So there is no order in nominal scale, but there is an order in ordinal scales. Okay, so that is the second scale. The third one, the interval scale. This is a numerical scale. Okay, and then the best example is temperature. This scale doesn't have true zero. So when you say the temperature is 0 degrees centigrade or Celsius, you cannot say that there is no temperature, right? Temperature still exists. So it doesn't mean the absence of a variable. Okay, it just means it is cold. So that is the interval scale. So you have no true zero value. So you cannot say 10 degrees Celsius is 2 times hotter than 5 degrees Celsius. No, there is nothing like that. So this scale is called the interval scale. And the last one is the ratio. That is the highest order of measurement, the ratio. So there is true zero. This is also numerical. So you can have like income. Income is a ratio variable, right? So true zero exists. If you say a person doesn't have any income, it means his or her income is zero, right? So that's why in ratio scales you have a true zero value. Okay. So what you can do, you can make a pyramid like this. So nominal scale is gonna be here at the very bottom. Then you will have ordinal, and you will have interval, and finally you will have the ratio variables. Okay? So that's the level of measurement, basically. There are some examples for psychology that important. We may talk about distributions. Distributions are important, right? Whether they are discrete or continuous, but they are important. Let's look at this example. I recently purchased a bag of plain M&Ms. Oh, yummy. The M&Ms were in 6 different colors. A quick count showed that there were 55 M&Ms, 17 brown, 18 red, 7 yellow, 7 green, 2 blue, and 4 orange. So what we can do, we can list these counts, right? We can have the color here. And then we can have color on the column, and the other one, the frequency is in another column. Okay, so we have brown 17, red 18, yellow 7. It goes like this. So that's the distribution. It's called the frequency table. Okay, frequency distributions. We can also have frequency distribution like this. This is called bar chart. Okay. We will get to these concepts later. Brown, red, yellow, green, blue, and orange. And then with this bar chart, as you can clearly see, you have the least number, right, is for blue M&Ms. And then you have red M&Ms. They have the maximum number. Okay. This kind of their distribution. We can also do the math to get the proportion. That's an easy concept, right? Proportion. Let's do one. At least a couple of them. Let's do a couple of them. So it means how many M&Ms we have? We have 55. So let's get the proportion. How many brown M&Ms we have? 17. So the proportion will be 17 divided by 55. Okay. Which is 0.31. 18 divided by 55. 0.33. 7 divided by 55. 0.13, another 7, 0.13, and we have 2, 0.04, and 0.08. Ideally, it has to add up 1, but because of rounding, sometimes, it may be off a little bit. Don't worry about that. So that is the proportion. So we can have the bar chart for the proportion too. So here is the bar chart for proportion. Okay. It is just another way of showing the data. Okay. So we may talk about continuous variables. For continuous variables, you see you have the response times, right? Since we are measuring time, it means it is continuous variable. Okay. We can have grouped frequency distribution. We have the values, the range, okay? Okay, don't forget, when you have a range like this, you need to find midpoint for most calculations. And then to get the midpoint, all you do is you just get 500 plus 600 divided by 2, which is going to give you 550, 650. It will go like that. This is called grouped frequency distribution. Not that difficult. And then that's the histogram. This is really one of the best way of showing continuous variable or continuous data. Is called the histogram. As you see in histogram, you have like a continuous scale throughout. But we don't have any values here. But for that part, it is just like a whole big chunk. It's called histogram. Okay. You will hear this concept a lot in this course. It's called a normal distribution. And then we use this distribution heavily to calculate probabilities, to establish confidence intervals, and then to do hypothesis testing. So normal distribution, we would like our data to follow the normal, distribution. You see that distribution is symmetric around the mean. So we will have a mean of this distribution. And then this part is going to be 50%. And this part is going to be another 50%. So that's basically a probability distribution. It's called normal distribution. Okay. Shape of distributions. When we think about shape of the distributions, we can take the normal distribution as like a base point, okay? Like a base point. So it means if something is non-normal, there will be deviations from normality, okay? Let's look at this one. As you see, there is a tail, right? Tail to this part, to the right. So this distribution is called right skewed. When you have the right skewed distribution, what you will have, your arithmetic mean will be 99% of time, I would say, mean is going to be greater than median. So by just checking these two values, you can get the skewness. So you will have a positive skew or right skewed. Okay? You see, that's a very large positive skew. Look at this tail, long, right tail. Okay? So very large positive skew. Okay. Like this, continuously with a positive skew. You can see it. Okay? This is less common. It has a negative skew, as you see, and the tail is towards the left, okay? And then this is skewed to the left. So in that case, what you will have, mean is going to be less than the median. So that is going to be left skewed. Okay. As you see, tail here. That's an interesting distribution. As you see, there is like two modes, right? Modes is the highest frequency, right? The Y value with the highest frequency is called mode. You see, this distribution has two modes. So from the Latin language, it's called bimodal. Bi means two in Latin. Okay? In Greek, basically. From Greek to Latin, so it is bimodal, so it's going to be two modes. It's a bimodal distribution. Okay, also we can talk about kurtosis. As far as kurtosis is concerned, this normal distribution will be the baseline. Okay, so if you draw a distribution like this, this is normal. You may have something like this, and then you may have something like this. You see that one is going to be called leptokurtic. And this one is going to be called perikurtic. And then in some books, instead of normal, you may see mesokurtic. Meso also means in the middle. Okay, so this is the kurtosis. So two important concepts as far as normal distribution is concerned. One of them is the skewness. So you may have a distribution right skewed or left skewed. And the other concept is the kurtosis. So you have a, like, it could be like a steeper than normal distribution. In that case, it's going to be leptokurtic. And it can be even flatter than the normal distribution. Then it's going to be platykurtic. It's an important concept. Okay. Okay, we may talk about summation notation. This is kind of a math, just the beginning. So we have weight of 4 grapes. Okay, so those are the x values. So what is summation of x? Basically, summation of x means we take the x values and then add them up. So I is gonna be basically the bottom in this, right? Indicates the point. So xi means this is gonna be x1 value. This is gonna be x2, x3, and x4. So when I add these 4 values up, it is called the summation. It's another Greek letter. It's called sigma. In statistics, you should be very good at reading or at understanding the Greek letters. Okay? As you see, so they add them up, they got 19. Okay? So if it says from I is equal to 1 to 3, it means we will have the first 3 values added up. Okay? I think the concept is clear. How about total of x squares? So in that case, what we do, we take the squares of each value and then add them up. Be careful. Total x square and then total x square is not the same, right? Why? Because here, first we add them up and take the square. Here, we take the squares for each value and add them up. So we are talking about 2 different concepts. We should be careful. Cross products, it's easy. What we do is basically we multiply each x value with its corresponding y values, right? So 1 times 3, 2 times 2, 3 times 7. So it's going to be 3, 4, and 21. So it means the addition. So we add them up. 7, 21, it's going to be 28. So math is important. When you deal with statistics, math is really important. If we talk about linear transformations, when you have an equation, right? Like the feet and inches, some of you may know 1 feet is equal to 12 inches. Okay? So it means when we say it's 5 feet, it means it is 5 times 12, 60 inches. 6.25, 75 inches. It goes like this. How about the temperature, degrees Fahrenheit and degrees centigrade? We have an equation. So let's say if you have 12.22 degrees centigrade, so you just plug this value here, multiply it by 1.8 and plus 32. So it's going to be 54 degrees Fahrenheit. So that's a British system, right? And then this system is SI International. Okay. So the British and Americans, they are really familiar with the Fahrenheit. They are not really that familiar with the degrees centigrade. Okay. And then also you can have another formula. Just, this is the centigrade to Fahrenheit. This is the Fahrenheit to centigrade. Nothing really fancy about it. Okay. Of course, degrees centigrade, degrees Fahrenheit, it's going to be a perfect fit, right? Why? Because there's a linear transformation between the two. So it's going to be perfect fit. We will get to that concept later, but if you find the R square degree of fit, it's going to be 1 here in that case. Why? Because it is a perfect association between 2 variables. We will get to that later. Okay. Logarithms, and that part is not really important. I'm just skip this part. Okay, level of measurement. Chapter 1, okay, chapter 1. Here is some exercises. Okay. Let's see. Okay, let's give an example of an independent and dependent variable. Okay, let's say we have independent and dependent variable. Let's say the baking temperature. Let's assume we bake at 200 degrees Celsius, 250 degrees Celsius, and then 300 degrees Celsius. And then we measure cooking loss. Let's assume for a steak. So we cook steaks at different temperatures. So 200, 250, and 300 degrees centigrade or Celsius. And then we measure the cooking loss. So it means what we manipulate in this case is the baking temperature. So baking temperature is going to be our independent variable. And the cooking loss is going to be our dependent variable. Why? Because cooking loss will depend on the baking temperature. So what we expect is you increase the temperature. So X increases, Y will also increase, right? So you will have more cooking loss. Okay, let's look at this one. The categorize the following variables as being qualitative or quantitative. Qualitative means it is about the quality, the attributes. Quantitative means it's about numbers. So rating of the quality of a movie on a 7-point scale, basically this is gonna be qualitative, even though we will give the point, right? So we may even call this ordinal scale, right? A 7-point scale, but that's just the level. The age is gonna be quantitative. Country you were born in is gonna be qualitative, right? Favorite color is gonna be qualitative. And time to respond to a question is gonna be quantitative. There is some discussion about this rating stuff, but basically if it's a ordinal scale, you can call it qualitative variable. That there is some discussion as to this concept. Okay, so level of measurement used for the items. So we can say the level of measurement. This is the 7-point scale. We can call this the ordinal level. So the age is gonna be the ratio. Country you were born is gonna be nominal. Favorite color is gonna be nominal, right? Because there is no order associated with it. Time to respond to a question is gonna be another ratio variable, basically. Which of the following are linear transformations from meters to kilometers? Yes, it's a linear. Squaring each side to find the area? No, it's not linear, non-linear. From ounces to pounds? Yes, it's a linear. Square root? No. Multiply all numbers by 2 and adding 5? Yes. Converting temperature from Fahrenheit to centigrade? Yes. Here is a formula. Is this a linear transformation? Let's see. If a student got a raw score of 20, what is this test grade? Okay, test grade is G. Okay, so G is equal to 16 plus 3 times 20. So 60 plus 16, 60 plus 16 will give you 70. So 6. So it's a linear transformation. It says compute the following total of X, 1 plus 2 plus 4 plus 16, 3, 7, 23. Total of x squared, so it means 1 squared plus 2 squared plus 4 squared plus 16 squared. Okay, 1, 4, 16, and 256. So 256, 16. Okay, I believe 277. If my math is not wrong, I think it's okay. Total of x squared, so it's gonna be 23 squared. Let's do it. 529 will be the answer. We may talk about the skewness. Large negative skew, it means it's left. So it's going to be this large negative skew. It's going to be tail to the left. I think we came to chapter 2, graphing distributions. We may stop here. I hope you guys have enjoyed the lecture. I wish you good day. Bye-bye.